Okay, let's continue with the math. Close this lists.txt and then copy the first.txt to math.txt and then open the math.txt, change the title to mathematical expressions in latex. I will clean. Now we can add two kinds of equations in our LaTeX documents. One of them is inline equation and the other is, I don't know the name, the normal equations. For the inline equations we can use $1 sign, like you can say like Newton's second law is dollar. Let's use F equal ma first. F equal ma. Okay, this F equal ma is an inline equation because we use only $1 sign here. Or we can just say Newton's second law is dollar dollar F equal ma dollar dollar and dot, and these $2 makes this equation as outline equation or a normal type of equation. Let's see the output, you will understand. Run the code with PDF LaTeX math and then open the math.pdf with emins using the and sign. Now here you will see that the first F equal ma is inline, but the second F equal ma is not inline. It's not written here, it's written here as an equation in the middle of the page. And there is a dot here put in the next line here. If we continue writing, it is so-called the momentum equation. And save and exit and then run it. The rest of the paragraph will come here after this dot. But this way of writing the mathematical equations, mathematical expressions is not used that much in LaTeX. Why don't we use it? Because it doesn't put an equation number here. Instead, we can just use this way. We can take this in the next line and then remove these two dollar signs and then start here with begin equation and end here with end equation. Now here we can move this dot to here and we can continue writing our sentence. Okay, this is the second way. Let me write the first way too. Newton's second law is dollar dollar F equal ma. If I put the dot here, it will go to the next line. If I put the dot here, it will come to just here, ma dot. I will put here and then save and exit this document and run it. You will see that this dot came here and the new way of writing equation using the begin equation function as this one is written here. These two look exactly the same, but they are not actually. If you press F here, you will see that in the second one we have an equation number here. We need to number the equations because we can use cross-referencing in the PDF documents we prepare in LaTeX. So it's quite important. So we do not choose this one, but we choose this way. Let's put some comments here. Do not use this way. I will also write here, do not use this way, because this is not the best way. And the best way of writing equations in LaTeX is this. Use begin align. Write here f equal ma, and then finish with end align. But to use this align function in LaTeX, we need to use a package. So come here and import math packages. Use package and use, let me check, AMS math and AMSSYMB. Okay, I think the begin align can be used without these packages, but because in engineering we always have some complex equations in our reports, we need some special symbols that we need to use this package, and we need some special things to do using this package. Okay, so when we start writing a LaTeX document, I personally always use these packages in my LaTeX documents. Now let's check the new version we write using this way, but first write these sentences here. I copy it and paste it, and I copy it and paste it here. Okay, this is the third way. Now as you see, the second way, Newton's second law is F equal ma1, Newton's second law is F equal ma2. These two are exactly the same. I forget to put a dot here. Now they are exactly the same. Why do we use this one? Because we can align our equations when we use the align function. Like if we have some more equations, like let's say we have multiple equations we write here. Let's begin align x equals 3, y equals 4, z equals 5, and align. Then begin align x plus y plus z is equal to 12, and align. Okay, now here we can use these multiple equations when we use align, but not using like this. Let's first put this y, 4 y's, and let's put this variable like 2, 4, 6, 7, 8 z's. So 1, 2, 3, 4, 5, 6, 7, 8, and this y is 4y. Let me be sure that I write the same thing. Okay, I'm not making an addition here, I'm just writing equations. Okay, this is not Python, this is just LaTeX. Whatever we write here, it will write that one. If we write 13, it will write 13. Okay, please don't confuse. Now this is a sentence actually, so we need to put some comma and we need to put some dots. Let's x is 3, y is 4, z is 5, then x plus y plus z is 12 dot. Okay, our sentence finishes here, so we can put dot. If we run this way of writing equations, we will see these x, y, and z definitions will come in one line. Let's see it. But we don't like doing this. Okay, we want to put this y under x and z under y. To do that, we can use two backward slashes in the align mode, not in the equation mode. Okay, when we use the align, we can use these two backward slashes to send this line to the next line and this line to the next line. Okay, then run this again. As you see, this x, y, and z came here, and these equal signs are aligned. But let's say we have like 500 here and 40 here, then our addition will be 543. Run it again. Now these equal signs are not aligned. We can also align them when we use the align function by just putting and signs here before the equal signs or after the equal signs. Wherever you want to align your equations, you can put these and signs here. Then it will put these ands aligned. Then we will see these equal signs are aligned. Okay, so this is the other reason we use the align function. Okay, so this is the way people usually use when they write these kind of multiple equations in order. Here we can also put these and signs like before x, before y, before z. Save, exit, and then run. As you see, now they are aligned here. Okay, but we usually use it just like this. As you see, I put some spaces here in the math mode, but those spaces are not here. So in LaTeX, the spaces doesn't mean anything actually in the math mode, in align mode, right? But we cannot, maybe we can, but I don't know how to do. We cannot align this equal sign to this equal sign because there's then here. Okay, if there is a way, probably there is a way, but I don't know, but it's fine to use like this. Okay, so writing equations is usually made in LaTeX in using this align command. Okay, now in GitHub we have a complex equation. Here I prepared a document to prepare the Navier-Stokes equations of incompressible flows, but this document is quite long, so I will copy this document and then I will paste it in my Navier-Stokes.txt file. Navier-Stokes.txt file. In the insert mode, I right click and then paste. Let me check if I add my titles and anything correctly. I think there is a problem by pasting this document because colors doesn't seem good to me, but let's try to run it. PDF LaTeX ns. Yeah, it's okay. Now we have the ns.pdf file. Open it with the events. When you use events, I think you don't need to use the extension. Let me check. No, you need to use the extension, but when you compile the PDF LaTeX comment, you don't need the TX extension. Okay, now this is our new document. There are some equations here. So these are so-called the Navier-Stokes equations in fluid mechanics. These are the fluid mechanics governing equations. and they are written using this document. Let's now check what we did here. Now here I put a tilde here. Okay, tilde means I want to give a space here to for my TX files looking good, not so complex. Like if I don't put a space here, so after the as follows, the begin directly starts. I want to separate them from each other, but I don't want to give a new paragraph to here, so you can just use tilde instead of space. Okay, so this tilde makes this one and this one in the same paragraph, but there's a line here in the text file. It's not something important, but if you do that, your TX files will look not that complex. And when you write like sentences, like this one for example, 3 line including 2 sentences. If you write these kind of sentences, you can just put the second sentence next. And if you write an equation here, for example, you can put this equation in the next line. So when you want to change this equation, you don't need to go to here. You can just go to down from here. Okay. But for now, we don't have that equation here. So I will redo it. Now here, I started with the align function. I write here the Navier-Stokes equations are fluid mechanics governing equations. There are 2 tilde here. In English, if we use 2 names, doesn't relate to each other, I think. Don't relate to, I'm not sure about the rule, but if they are not related to each other, like what can I give? Okay, I couldn't remember any example to put 1 tilde, but Navier and Stokes are 2 different people, so we use 2 tilde here, 2 tilde here, and latex makes this tilde, no, it's not tilde, this is hyphen, this hyphen is long hyphen. Okay, we use 2 hyphens here, and latex makes it long hyphen because these 2 names are not related to each other. Okay, I don't know the rule, please check it on the internet. Then we write this equation here. We have rho density, and the sign of density is just rho here. Rho is a Greek letter, and if you cannot remember its name, but if you know that this is density, you can just check it on the internet. What is the Greek letter representing density in fluid mechanics, for example? Okay, there are lots of people using latex on the internet, and so you can find all this kind of information on the internet. Now we have a large parenthesis here. To put large parenthesis, we need to use this left and then parenthesis. Then we have defrag here, which makes this division. Okay, if we put frag, this division will be smaller. We use frag to put divisions in the inline equations, but we use defrag to put divisions in these kind of normal equations. It makes this division larger, and this u, for example, is the same size as this u. So using defrag is quite important, I think. The left is here, I said. There is a division which is represented with this defrag. Now, when you use this defrag, you need to use 4 curly brackets. 2 is opening, 2 is closing. Now, I opened this one, and then I write partial u. This partial sign is this one, partial or partial derivative, and this u is capital, made using this mat BF. We learned that in the text mode, we can make bold characters using text BF. In the mathematical expressions, we can make bold characters using mat BF. Okay, this is bold because u is velocity in fluid mechanics, and it's a vectorial quantity. So we use vector quantities in bold characters. Okay, now we write this one partial u in these two curly brackets, 1 and 2. Okay, and in the second curly bracket and third curly bracket, we use partial t, which is represented in the bottom of the division. Okay, then plus sign came here, plus, then met bfu, again a vector quantity, velocity is here. Then there is c dot here, which is shown as central dot here, which makes dot products of two vectors. There is nabla operator here, and nabla operator is also a vector quantity. To make these kind of spatial letters bold, we cannot, maybe we can use matbf, but I'm always using p and b. I don't know the reason. So we use this p and b and nabla to make this nabla bold, and then we are here, nabla, and then we also have another matbfu here. Then we have minus bold f, minus bold f, which is the external force. Then we close the large parentheses here, minus nabla dot sigma, minus nabla, which is bold, dot, which is central dot, sigma, which is again bold. Okay, and equal to 0. 0 is also bold here because this is not scalar 0, this is vector of 0. So if you are working on like two-dimensional models, so this is a vector 0, 0, three-dimensional models 0, 0, 0. Okay, so this is just vector, so this is bold. But here dot product of two vectors gives us a scalar value. This 0 is not bold, and it's just written as 0 here. Again, nabla c dot u here and nabla c dot u here. This equation is written in the next line, so we use this one, and we aligned these two equal signs by just putting this and here and this and here. Okay, so this complex equation is written here from this begin align. Let me make it a little bit smaller to show you everything, from this to this. Okay, actually it seems complex in the first time, but when you start writing your equations in latex, you will understand that, you will see that it's much easier than the other programs that you can write these equations. Then we have some explanation about the Navier-Stokes equations in this paragraph. We have another equation here and another equation here. As you see, as I just talked about, I have some inline equations, like I'm writing here. Here, rho is the density, u is the velocity. Where is that? It's here. Here, rho is the density, u is the velocity. I'm writing in the same line, but I'm putting the equations in the next line. So if I want to change my rho sign, like with gamma, you can just come here and change it. If you want to change the external force sign to capital F, for example, you can just come and change it. But if you write them like this, then it's quite difficult to go there and then change the F. Okay, so this is the reason why I'm personally writing my equations in the first column in my text document when I use Vim. I cannot imagine when I'm using these, when I'm writing these using gedit. For example, use gedit to open ns.tex, you will see this document here. Equations are here, and to change the f, you need to find the f first. F is here, then you need to click here, remove it, and like this. Then you always need to use mouse, and it will quite time consuming. It will be quite time consuming. Okay, so this is the reason we use Vim on the terminal. I will close it without saving and open it with Vim again. And this is an example to write complex mathematical expressions. I showed here how to write nabla, for example, sigma, like how to write capital letters, row density, etc. But there are some other things you may want to learn, like times, cross product. There is no cross product in that equation. Or O times, which is dyadic product, or like square brackets. We use this way of writing large parentheses, but you can see that you can also make square brackets, large square brackets, like fully covering the equation inside. This is the partial sign, like P and B function is used to make the Greek letters bold. And if you need, like, for example, capital gamma, how to make capital gamma, you can just click on this link and you can find everything about the characters, like Greek letters, nu here, kinematic viscosity, or like tau here, stress. You can find a small omega here for angular velocity, or you can find how to write like not equal sign, smaller than sign. Okay, if you want to make this sign, you can just use this one, for example. Or if you want to make it like this one, you can just use this one. Okay, there are lots of options in this web page. You can check it when you need it. Now I will go back. Okay, we can add some sections and subsections into our documents. I think you learned how to make the title, you learned how to start the document, etc. So I will just copy this one from here, and then I will go to my terminal page, save my ns.tx file. Now here I have lots of files, but let me first paste the sections.tx file. Right click and paste, save it and exit, then list the files. Now I'm not using this first.log, this log, this aux, this math. I'm not even using these files, so I can remove all the aux files and all the log files from my directory. I can also remove all the PDF files from my directory. So I only have the tx files. If I want to see what does this list.tx do, I can just run pdf latex list.tx later, and I can open the list.pdf with events. I lost nothing, as you see. Okay, and if I don't need them again, I can again remove the PDF files, and I can again remove the aux and log files. I only need to keep these tx files with me to work on them later. Okay, now let's close these PDF files, we don't have them anymore, and list the files. We are now working on this section.tx. Open the section, first run it with pdf latex section.tx, and then open the section.pdf in the background, and then open the section.tx to see what we do here. Now we can add these kind of numbered titles or sections or subsections or these kind of subsections in LaTeX that easy. We can just write a backward slash section, and in between the curly brackets we can write our title. Then we can write our paragraph in that title, and then we can write subsection and write our secondary title. It will automatically number it 1.1. If we write another subsection here, it will automatically number it 1.2. Okay, this is something good in LaTeX, and we can also move them. Like, let me copy this third part from here. I just selected with Shift V. I go down with the arrow keys. I pressed X to cut. Then I go up and paste them here. Okay. Now my first number title will be the third part now, because the third part is here written before the first part. Okay. Now save and exit and then run the PDF. You will see that this part came here, and the number of this title is now 2 because I only have 1 above. Okay. Working with sections and subsections in LaTeX is this easy. If you use like LibreOffice, for example, I just pressed the Windows key and then typed LibreOffice in the search box, and this Microsoft Word like open source LibreOffice program opened in my Ubuntu. Okay, this is open source, you can just use it. Like, we can use here title 1, first title, for example, and then we can write something here. In the second subtitle we can write 1.1 first subtitle, and then write something here, then second title, then write something here, and then the first subtitle of second title, first subtitle of second title. Now we can prepare our document like this, and we can save it as PDF file by choosing here the PDF, I think, or we can just export. Actually, I have never used this one. Yeah, export as PDF, for example, here. But if you want to change these, cut these from here and like paste them here, then we need to change all of these items again and again. Okay, and it's possible that quite possible that we make some mistakes when we do that, but in LaTeX the numbers came automatically like this. We can change the places, and also even we can use different files to put different sections. Now we have this lecture 11 folder and lots of files in it. Let's make a sections folder, then move sections to sections folder, then go to the sections folder. Now we have only section files here. Let's open first part.txt, but don't use underscore here, use capital part here, first part.txt with section.txt using hyphen small o. Okay, then go to the this section.txt with Ctrl WW and cut this first part of your document with selecting with Shift V, going down with the arrow keys, and then pressing X, and go back to the first part.tex with Ctrl W, and then paste with P. Now press colon and then VQ all, type VQ all and press enter. Now we have section.tex and first part.tex files. In the section.tex we can just input first parts.txt file, and then we can save and exit. Then we can run the section.txt. You will see the output will not change, but in the section.txt we don't have this part, right? But okay, this second.pdf is not that second.pdf. Let me first open this section.pdf, but not like this in the background. Okay, this is the new one, and then open the section.txt. You will see that there is not this part, but we just used an external file to add this part here. We can also use a second part.txt, and we can open second part.txt in the same directory using the split command in Vim, and we can go cut actually, and then we can paste them here, and then we can save and exit all. When we run the new section.txt, you will see that our PDF file doesn't change. Now you can change the order changes and the numbers are updated. You can divide them, like open second part.txt and open a split third part.txt file. Copy this last line, paste here. This is my third part.txt now. Save all and exit. Open the section.txt and put here the third part. Now I think the second part will be on the top now, and then this part will come, and then this part will come. Okay, I'm just playing the order of the parts of my TEX files. Okay, the second part came to the end after I made the last changes. So you can write a main TEX file, and you can read some external TEX files to write different sections. You can also write like math.txt begin align mathbf f is equal to m mathbf a, because in the Newton's second law f is a vector, so it should be bold. A is acceleration, it's a vector, it should be bold, and m is the mass, which is a scalar quantity. Now I just typed math.txt and I put an equation here. I save and exit, and then open the section.txt and put input math.txt here, and you can put it everywhere like this. Save and exit. You will see three equations here, which are all the Newton's second law. Run the section.txt. Environment align not undefined. Okay, in the section.txt we don't have math packages, so import math packages, use package AMS math, and let's use AMS SYMB, I think. Let me check it. SYMB or SYMB, okay. Save and exit, then run the PDF LaTeX. Okay, now 3 equations came here and they are all numbered differently. Okay, so we can play with the TEX files to reorder them again and again using this method. We can just use some secondary files. We can also like make a parts folder, and we can move this first part.txt, second part.txt, third part.txt, and the math.txt to parts. Now our main folder sections are not that crowded now, okay, and all the parts are in this folder, but we need to define the location of these files by just putting parts here. Okay, then run the section.txt. It will again read the files in the parts folder. Okay, now we will learn how do we insert images in LaTeX documents. I will go one back, and then let's make a directory so-called images, and then go to that file, then copy, don't copy, just copy the file from here. Now inserting images is explained here in the lecture 1 repository. We can just copy this code to images.txt. In the insert mode, I paste, save and exit, then open it again to make the colors updated. Now here what do? We start with the document class. We use the package of geometry to set the paper sizes. We make the title, and then we insert some packages for reading the images from outside, or inserting the images from outside to the PDF document. The first package, actually the only package, is the GraphicX. Okay, GraphicX package is inserted into LaTeX to read the graphics from outside. And this line, graphics path, here there is no X, this is X, this is S. The graphics path refers the folder that our PDF or PNG images are located. Okay, now please be careful here that always we use one curly brackets, but here when we define the graphics path we use 2 curly brackets, and this forward slash should be here. Okay, now we defined where we locate the files. Then we can just use begin figure, include graphics, and end figure to import some figures into LaTeX documents. Here begin figure and end figure is exactly quite similar as like begin align and align, but here there's include graphics. Now this include graphics is used for reading the images from outside. From where is this PDF file? It is here in the figures folder. Okay, so in the same folder we use, in the images.txt, next to the images.txt we need to have figures folder, so we need to make the figures folder. Okay, In the images.tex file, we read this population.pdf file. Where is that population.pdf? If you join the lecture in the last week, you can find it from in your home directory, like lecture 10. You should have this population.pdf here, or if you don't have that, you can just download it. If you don't have that image, you can use this new plot script and this text file to make it. Okay, click on here to see the new plot script. I will fix this link when you watch this video, and click on here to see the text file. I will also fix this link, and then make that PDF file. All right, now here I will copy the population.pdf to my figures folder, and then in the figures folder I have the population.pdf. Now I can run this images.tex. If I open the images.pdf in the background, you will see that the figure came here. But this figure is not located good. Actually, I want it to in between these two sentences. As you see in my text file, I write here, this document includes a figure. This document includes a figure is here. And figure above shows the population changed, blah blah. Figure above shows, but figure is here, but it doesn't come to in between these. To put it there, we can use this H here with the square brackets after the begin figure. Okay, save it and exit after adding the H, and then run it again. You will see that the figure came here. If you look at your PDF file from outside, the figure is left aligned. So in the figure, in begin figure, we can just put this centering. I'm not sure if this one works. Let's try first. Yeah, it works. When I put the centering, it puts the figure in the center. I said I'm not sure because I usually use this begin center here. I'm not using this, and end center, but using centering is shorter surely. Now our figure is in the center, but there is no caption in our figure, so we can add a caption like population in 3 different countries. Okay, after the captions we usually don't put dot here. It's again something like most people use us this way. So after the captions we don't put dot, even if it's a sentence. If we have a 2 sentence here, like population in 3 dot different countries, we don't put dot at the end. Okay, now save, exit, and then run. So our caption is here now, figure 1, which is numbered automatically, and then population in 3 different countries. You can also change the type of writing this figure 1. You can remove this dot from here. You can make this bold. Whatever you want you can do in latex actually, but you should check it on the internet. Now we add the figures. Let's check. We can add tables in latex, but before that we can also arrange the figure size. Let me also show it to you. Here, after the include graphics, we can put square brackets, and we can write here width equals something inch. Now our paper is, I guess, something like 6.5 inches. So if we set it to 6.5 inches, the figure will start from here and end at here. Do it, but please don't forget to write in here, inch. Then when you run it, you will have bigger figure. But the important thing here is not seeing figure bigger, it is seeing everything in the figure in the same size as the rest of your document. Like this P, or I don't have U, capital U or something here, let's check. Okay, like this P should have the same size as this T or this G or the other capital letters. Okay, so when we make this document in new plot last week, we choose the size of the document as 4.5 inches and 3.5 inches. So if you want to see this graph as big as this one, you need to set the size in new plot, not here. So using the same size, which is 4.5 inch in width, here is the best way of using this document here. Like Turkey T and P are almost the same size. Okay, so we don't have figure doesn't look bad now, but the fonts are different. Here last week we used Times font in new plot, but here we use the default font of latex, which is Computer Modern Roman. So these are different, but I'm not going to teach you how to fix them. Actually, I taught you how to change these to Times, but I don't know how to change these to the default font of latex on new plot, because we will use PGF plots, which we will learn next week, to make these kind of graphs. Okay, as we talked about new plot last week, we usually use new plot not to prepare documents for reports, but to check the graphs on the terminal window quickly. Okay, these kind of documents are prepared in PGF plots, which is a part of latex, which we will learn in the next week. Okay, now we learned how to insert images like this. Next, we can add labels and we can add cross references. We have a long document here. Let's copy this long document and talk on it. I copied it. I will open my terminal. I will go back from the images folder. I will make like labels folder, and then I will go into labels folder. I will open labels.txt file. I will go to the insert mode and then paste the document here. Save, exit, open back. Actually, save, exit, run PDF latex, labels.txt. Okay, I don't have population.pdf. I will copy the figures folder from images to here. Copy images figures folder to here. Why I'm not? Okay, I need to use -r. Okay, I have figures here and I have population.pdf in it, so I can run this PDF command pdf label.txt, and then I can open the labels.pdf using the events in the background with the and sign. Okay, now this is the documents, two documents actually we have written recently. One of them is the figure part, one of them is the equations part. In the labels.txt, both parts are written here. I didn't separate them into different files, which I usually work, but I will show you how to make labels now. Here, after writing the section, we can add a label here. We can write anything we want here, but most people usually use like this sec colon and the name when they label the sections. And like there's another label here labeling the subsections, and they use subsec colon the name to label this subsection. Okay, so if we want to refer this subsection, figure part subsection, somewhere in the document, we can just use this label, and we can use this ref function of latex in the document. So here we say that this document includes a figure label here, fig population. Where is the fig population label? It's here. We learned how to insert this figure here. I said I use begin center always. Include graphics. I put the width 5 inches. I read the PDF file. I put an caption, and then I put a label here. I'm now referring this figure in this paragraph, and I'm saying that figure tilde. By putting a tilde here, I'm saying latex put a space here, but do not put this figure and number in different lines. So put this one completely in the same line. Even if I'm here, I'm writing at the end of a line. Okay, so if I'm writing here figure 2, for example, it will either write figure 2 here or write figure 2 here. Okay, it will not write figure 2 by putting this tilde. So we always use that tilde. Don't think that you are writing this one in the middle, like this is in the middle now, but you can just add a sentence here and it may change later. So always use this tilde when you refer a figure, tilde refer the figure, section, tilde refer the section. Okay, and this ref function is used for referring. This fig 2 dot population refers this one, and this subsec 2 dot or colon figure part refers this subsec colon figure part. So it writes here the document. This document includes a figure. Figure 1 is given in section 1.1. This document includes a figure, and figure, the name of the number of the figure is now 1. But if we add another figure here, again we will refer this page, this figure, and this figure number will be figure 2 then, and this part will be updated automatically. Okay, and this section name maybe will be maybe we will add another section before this, the first section, and this one will be 2.1 then, and this one also will be 2.1, because here we refer this figure parts subsection, this figure part subsection here. Okay, wherever we put this label, we refer the line before the label line. Okay, now if you put this label before the caption, then you cannot refer this figure. It has to be after the caption. The label of sections has to be after the section names. Okay, we can also refer some equations here. Equation V1, or we also refer it here. Equation 1 and equations 2 and 3 are given in section 1.2. I'm referring this equation and equations 2 and 3 given in section 1.2. Let's find it here, where I'm writing that here. This document also includes some equations. Equation 1, it's written here, equation 1. Equation, refer the equation Newton. Let's find the equation Newton. Equation Newton is here, right? Label is here. So I'm referring this equation. What is that equation? F equal ma. So this is the Newton's second law equation. So I'm referring that equation here. And equation Lin-Mom, which is the linear momentum equation in fluid mechanics. Equation Lin-Mom is here. After this equation, it is written, the label is written, and it says equations Lin-Mom and equation continuity. Equations Lin-Mom and continuity. So it is the second equation given here. Okay, I found it and then refer it. But please notice that here that equations are referred in parentheses like this, and these parentheses can be put here manually like this one, parentheses and parentheses. Okay, or we can make some definitions here in the latex document, but I will not teach it how to do that. Okay, so when you refer an equation, please put parentheses like this. Now these are here, but these are not just numbers, these are also links. When you click on this 2 here, when you come here, as you see, my mouse pointer changes to hand. Okay, so you can click this 2. When you click on this 2, it will show me the second equation directly. Or like when you click on this 1 it will put this 1 here on the top. Okay, or when you click on this 1, it will put this figure 1's caption here. Okay, because we refer the caption actually. And if you put this section 1-2, the section 1-2 will come here. We can also add these kind of links into our table of contents and list of figures and tables. Let's see the next video for the lists and tables of contents.